Hello, this is Basic Chemistry, Chapter 10 on Structures of Solids and Liquids. And we're in 10.1 today on electron dot formulas. Electron dot formulas are some of the easiest and most useful things you're going to do as you're looking at how molecules work. Electrons are circling the atoms, and the very outside shell of electrons are called the valence shell, just like a wedding veil is on the outside of the bride. So valence electrons are the electrons in the S subshell and the P subshell. Okay, so in a periodic table, that's the first two columns and the last six columns. So columns 1, 2, and then the last six are the valence electrons. So there's a total of 8 valence electrons. Electron dot formulas will show you how many of those 8 you have. So you're either going to have 1 dot, or 2, or 3, or 4, or 8. Okay. Now, in order for the electrons to, let me say it this way. In order for the octet rule to be met, if you remember, the octet rule is that every atom wants to have the same valence shell pattern as a noble gas. It's the most stable of all of the atom configuration. So if you can get 8 electrons in the valence shell, you're the most stable. And atoms will react with each other until every atom in the compound has a valence shell equal to a noble gas configuration. So in order to know whether it is sharing, okay, how many it's sharing, you would use electron dots. Now, it doesn't really work well when you're talking about ions, because you just end up with a 1 charge and a -1 charge, and then they come together, or a 2 and 1, or a 1 and 2, or a 2 and 3, where they're all kind of coming together, positives and negatives. But if you're sharing electrons covalently, knowing how many valence electrons, because it's the valence electrons that are being shared, so knowing how many each have is extremely useful. Let's do some examples. Okay, aluminum is in group 3. So we're going to have 3 valence electrons, 1, 2, 3. Silicon is in the same as carbon, so it's 4. Phosphorus is in group 5. Sulfur is in group 6. So what group it's in, what column it's in, will tell you how many dots to put around it. Now, there's normally a rule, okay? Let me go ahead and show you. If this is our generic atom, this is 1. 1 is put somewhere on the right, and then 2. So 1 and 2 together. Then 3, 4, and 5, and then go back and do the other, 6, 7, and 8. But honestly, it so really just doesn't matter. So in the case of 3, just don't put any together, and then when you get to 5, you'll have a lone pair. This is called a lone pair. This is a bonding electron. Okay, so let's say I've got hydrogen, and a bond is a shared pair of electrons. So I can end up making a bond. So knowing how many valence electron by Lewis dot structure, the Lewis dot symbol, tells me how many things can I join with. Like this doesn't join with anything. Now you could have something that had nothing come in and share it, but for the most part, this doesn't have any attachments, and this will have attachments. Now later, when we get into the shapes of molecules, you can tell, I know what shape that's going to be, or I know what shape that's going to be. Okay, you can predict it simply by knowing how many hands it's holding. All right, so here is group 1A. Group 1A is 1s or 2s or 3s1. Okay, so everything that's S1 is in the 1A. It will have 1 electron. So the S's and P's, remember, are the 1 through 8. So S's, there's 2 of them. Okay, there's S1 and S2. So the first 2 columns and the last 6 columns. So the last 6 columns are in the P's, the P subshell. So this will be 1 through 6. So when you have the S1, S2, and then P1 through P6, that's your 8 valence electrons. So anything in the first column will have 1, lithium, sodium, potassium. Anything in number 2 will have 2, beryllium, magnesium, calcium. Then 3A, boron, 4A, carbon. Do you see it? There's 5, that's nitrogen. 6 is oxygen. So once we end up with nitrogen, we have a pair that's not going to attach to anything. Once we end up with oxygen, we have 2 pairs that's not going to attach to anything. And then once we get to the group 7, we have 3 pairs that doesn't attach to anything. And then once we get to group 8, nothing attaches. You have 4 lone pairs, and normally you have nothing at all. Okay? So if you have neon or argon or krypton, they don't make compounds. They're already stable. Okay? They show the sequence of bonded atoms in a molecule. So you know where they're attached to each other and where they could attach to something else. It shows you the non-bonding pairs, which are called lone pairs, where there's no attachment, and the bonding pairs where you would find an attachment. The atoms with octets, except for H, okay, it only needs 2. If you remember, H is in the first shell, row 1, period 1, and it's hydrogen and helium. So it's completely filled. Helium is a noble gas configuration, and it is 1s2. All right, so 1s2 is full. So hydrogen is the exception. It only needs to hold hands with one thing, and it doesn't need an octet. It only needs a duet. So hydrogen needs 2. Everything else needs 8. And if you can get it to be 8, you know that you've made a compound. So here's an example. This is chlorate. Write the electron configuration from chlorate. All right, so I've got 1 chlorine and 3 oxygens. Does it make sense that chlorine probably is your center atom? Okay, because I guess you could put the oxygens in a circle or something like that. But my thinking is I'm just going to try it this way. If it doesn't work, I'll erase it and try it again. Let's do chlorines. Let's do oxygens first. Okay, 1. It's in group 6. 2, 3, 4, 5, 6. Okay, so oxygen can hold hands with 2 things. All right, so here's another one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. Now, chlorine has 7. So it is 1, 2, 3, 4, 5, 6, 7. We want some way that these can connect. Also, this is an ion. So the whole thing has got to be negative. All right. So let me start over. I'm going to assume the chlorine is central, since I've got the oxygens can kind of go around it. So let's see if it works or not. All right, let's do a connecting pair between each one. So there is a shared bond electron, so that's a bond. That's a chlorine bonding to oxygen. Okay, here's one, an oxygen bonding to chlorine. Here's one, an oxygen bonding to chlorine. All right. So what else do we have? We've got 1 electron more, okay, because the whole thing is negative. All right, so we're going to have to add 6 for that electron because it's in group 6 for that oxygen. We're going to have to add 6 electrons for this one because it brings 6. It's in group 6. We're going to have to add 6 for this one because it's in group 6. And we're going to have to add 7 for the chlorine because it's in group 7. Group 6 has 6 valence. Group 7 has 7 valence. All right. So what is that? That's 18. 3 6s are 18. 19, 20, 25. Okay. 25 plus 1 more. So I have 26 electrons to play with. So here's 2, 4, 6. All right. So here's 2, 4, 6. Now just start going around. Okay. 8, 10, 12. Now oxygen is filled. 14, 16, 18. Now that oxygen is filled. 20, 22, 24, Did I do it right? Okay, there's 26 electrons. Let's do it again. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Okay, so I have 2 more. Where would they go? They go here. Okay, they go around the chlorine. So my answer is going to be chlorine, oxygen, 2, 4, 6, oxygen, 2, 4, 6, oxygen, 2, 4, 6. And the whole thing is going to be -1. This is your answer. Okay, that's the electron dot formula for chlorate. You can see that you start by finding out how many valence electrons each of them have, add them up, add any charges that the entire ion would have, then distribute them all equally. Okay, you'll need 2 for a bond. There's a bond, there's a bond, there's a bond, and then just try to give each one an octet. And if they can be given an octet, then most likely that is a molecule that could exist in nature. All right, great.